Hi folks, let's talk about async network IO wait type. Now in forums, we sometimes see questions around wait stats and wait types, and we try to understand why a certain wait type shows up high wait time. Now these are common ones that keep coming across, like CX packet, page IO latch, let's say resource semaphore, so on and so forth. One such wait type is async network IO. Now async network IO is kind of a bit misunderstood because the name says async network IO. We kind of tend to think that this has something to do with network, or it might have to do something with IO. Now if you see async network IO showing up a high wait time, it might not really have to do anything with network or IO at all. So this demonstration, this tutorial is again based on questions that we see in the forum, and I want to demystify what async network IO really mean. So before I talk about this wait type and why do you generally see high wait time, let me run a query. I will first run the query and then we'll talk more about async network IO wait type because the query will take some time to execute. So while the query executes, I can talk to you. Let's do that. So in AdventureWorks 2016 database, I have this big table, DBO transactions. It has a few million records. I'm going to punch in a query here. I'm going to just write select star from dbo.transactions. Very, very straightforward. Let's turn on actual execution plan and let's execute the query, and let's see how much time it takes. Now the moment I have ran the query, you would see the result set starts coming or starts being rendered on SSMS almost instantly. So if you see, the result set is being rendered on SSMS. Because this table has a lot of rows, it's taking a bit of time for the entire result set to be rendered on SSMS. SSMS here is acting as the client. So you have the SQL Server database engine and you have the client. It could be your .NET application or a web application. In this example, SSMS is serving as the client where the result set from the engine travels all over the network to the client. Now, for the purpose of this demo, of course, the server and the client are on the same box. So typically there is literally no network delay. But in real world, as you know, client is somewhere else, the server is somewhere else. So there is a network delay. However, the issue here is not about the network delay. I'm just kind of explicitly calling this out, that of course there is a distance to travel for the data packets. Now let's talk about async network IO. Async network IO, when you see high wait time and showing up in your top 10 waits, top 20 waits, etc., is to do with the delay in the client responding to SQL Server that yes, I have got the data that you have sent me. It is the delay in sending that acknowledgement by the client to the server. That's all it means. It might happen that the way your application is designed or programmed, SQL Server is sending a huge result set to the client. Now, it's not uncommon to see such application code where developers actually get all the data set on the client, then in the client, on the client, they do sorting, they do filtering, they do aggregations and whatnot. And you and I know that there are some best practices involved around this. It is typically advised that such set-based operations can be really done very well on the server side. SQL Server engine is superbly capable of doing all of that with huge result set. So why get thousands, hundreds and thousands and millions of rows on the client side and do all that work on client side? Instead, do all of that on SQL Server side and then just get a limited result set to the client. Typically, when you get huge result set on the client side, then there is a delay from the client responding to the server because it's processing that huge result set. This would result in async network IO, generally, typically. There could be some hidden things, but I'm not aware of those things. But yeah, typically this is what we have seen. Now, you know, those kind of application code where the client is processing one row at a time. This is what we call as row by row operation. Such kind of code work, such kind of code base would result in async network IO wait time. Now, when SQL Server Engine is waiting for an acknowledgement to come back from the client that yes, you've got the result set and it's being processed or whatever it is, then SQL Server Engine will register the async network IO wait type, and the wait time will keep popping up. The wait time will keep increasing. So what are the best practices here? The best practice here is very, very straightforward. It doesn't make sense to get those millions of rows on the client side. Do whatever you want on the server side and get just a limited result set on the client side so that the acknowledgement can be quickly sent back to the server, reducing the wait time for async network IO. Now, I do not really know why this is named as async network IO. Probably it just tends to say that, okay, for whatever reason for SQL Server, this is a network delay. Even a response coming back from the client is perceived as a network delay. So maybe it is termed as async network IO, but this is really what it means. Now, by showing you this simple example, now if you go and actually read on internet a lot about async network IO, you will come across similar things that I've just said, but there are no real demos or tutorials trying to show you this. So I thought, why not just simply show this to you, that if you see in this example, select star from DBO transactions, I ran a simple select statement. We are about to touch around 5 minutes. So this is like 4 minutes, 36 seconds, 37, and the processing is still going on. Now, even if this table has millions of rows, do you really think SQL Server Engine is taking so much time to serve the result set? SQL Server Engine is not taking time to send that result set. It's the client that is taking time to render that result set on the window, on the pane, and send an acknowledgement back to the engine, yeah, job done. So this is where the delay is, and we're going to check this out. I'm not sure if I turned on actual execution plan. If I did, I'm going to pause the video and I will run it again. So let's just wait for a few more seconds. Meanwhile, I hope you are getting the sense of async network IO, when that happens, where it happens, etc. Yeah, so nothing much to do with network, nothing much to do with IO. It's all about client responding back to the server that yes, the result set is received and an acknowledgement is sent back to the server. Still executing. Let's just wait for a few more seconds and I hope it will be done. Okay. Now, obviously this query is very, very straightforward. Select star from DBO transactions. I just kept it very simple so that we all understand that typically there will be no delay or wait for any other resources. It's just about reading data from the disk. Yeah, so there might be some page IO latch issues, etc., but not much. Okay, we are done. We've got a few million rows, and if you look at the status bar carefully, this is about 30 million rows that we have rendered on the client here. Now let's jump over to the execution plan, and you can see the execution plan very, very straightforward. You have the select operator, and all we did was a clustered index scan. If you take the cursor over the select operator, right click and go to properties and expand here wait stats. I love this because it's good. You could get the wait information only for this specific execution. Otherwise you had to set up extended events and whatnot. So for this specific execution, if you expand wait stats, there you go. You will see only one wait. Just one wait, which is async network IO. Look at the count, huge count, 252062, 250,000 times this class was registered. And if you look at the total wait time, this is 308845, about 300,000 milliseconds, 308845. Let's take this number. So if you see, wait time is high. Now, if such queries, if such workloads are running too many times, and obviously it was about getting this result set to the client, you can see how wait time will keep increasing, the magnitude of it. So let's do this. If you select this one by 1000, because this is in milliseconds, so let's convert it into milliseconds, and then, so let's convert milliseconds to seconds and then to minutes, just to see how many minutes did we wait. Okay, the query took, if you look at the status bar there, the query took about 5 minutes 56 seconds for total execution. This is the elapsed time. Okay, so let's copy this. Okay, now let's just execute this. You have seen everything else. Let me take this to a new window just so that I preserve the execution plan and all of this if I want to refer to that later. Now let's go and look at the number here. There you go. This is it. 5 minutes, 1 second, whatever it is, approximately the wait time associated with async network IO. And it was only because the client was delaying in sending the acknowledgement back to server that yes, all the data is received. It simply happened because we were sending a huge result set from server to client, something which should be avoided in a database driven application. Idea is that whatever I want to do with these millions of rows, everything should be done at the server end, and probably only the final result set should be sent back to the client, and try to keep it as small as possible. Of course, it improves the overall server performance, etc. Overall application performance, etc. There are also some more best practices or more symptoms, more reasons why async network IO may occur. Let's say the client application itself is slow. The client application itself has performance issues, or the client application is running on a web server and that server has performance issues, and there are issues and delays in communication. All that can result in async network IO going up. Alright friends, I hope this makes sense, and hopefully you're more informed and learned about async network IO. Do share this video with your friends and colleagues, do give feedback and post comments, and I will see you soon in another video. Happy SQL! If you like the content, give it a thumbs up, subscribe to the channel and click on the bell icon so that you're notified on new videos. Most importantly, visit SQLmaestros.com. There's a lot of SQL learning resources out there: video courses, master classes, lab kits, ebooks, blogs, hands-on labs, and a lot more. Follow us on Twitter @SQLmaestros and myself _Bansal. Last but not the least, do subscribe to our newsletters. See you soon in another video. Goodbye.